Hello, friends. Here there is a small review of the things which you have learned in the second semester. You have learned the topics from organic chemistry. If you remember their names, you have learned hydrocarbons, that is the compounds which are made up of carbon and hydrogen, alcohols, aldehydes, ketones, carboxylic acids, amines. Now, what you have learned in this topic? In alkane, you have learned straight chain compounds in which carbon atoms are connected to each other by single covalent bond. These are the saturated compounds. Then alkene you have learned in which carbon atoms are joined to each other by single bond as well as double bond. In alkyne, carbons are attached to each other by single bond and triple bond also. So alkene and alkynes are unsaturated compound. You have also learnt about branch chain compound in which second carbon, that is the middle carbon, is attached to the another chain of the carbon. You have also learnt about the alcohols, that is hydroxy group carrying carbon compounds. You have learnt about aldehyde in which CHO is a functional group and it is attached to the carbon chain. You have learnt about ketones and carboxylic acids also. So, you know about their nomenclature, that is common name system and IUPAC naming system. You are familiar with these systems. You have studied their preparation, physical properties, chemical properties and applications in various industries. Now, in this semester, we are going to deal with aromatic compounds. In the subject Chemistry of Aromatic Compounds and Dyes, we are going to study 6 different topics. First topic is aromatic hydrocarbons. The weightage given to this topic is 12 marks. Second topic is aromatic sulfonic acids, nitrocompounds and phenols. This topic is having the weightage of 10 marks. See, in this topic we are going to study 3 different types of compounds, that is sulfonic acids, nitrocompounds and phenols, and combinedly 10 marks are allotted for this particular topic. Third topic is aromatic amines and aryl diazonium salts. This topic is also having the weightage of 10 marks. In this topic, amines and aryl diazonium salts, which you will learn, plays very important role in synthesis and preparation of dyes as well as intermediate. Fourth topic is polynuclear hydrocarbons and dye intermediates. In this fourth topic, we are going to deal with polynuclear hydrocarbons, that is fused ring compounds like naphthalene and anthracene. From these compounds, we are going to prepare some dye intermediates which play important role in preparation of dyes. Fifth topic is elements of dyestuff industry. It is having the weightage of 14 marks, and in this topic we are going to deal with classes of dyes, method of their application and pigments. Last topic is dyes, structure, property and relationship. It is having the weightage of 14 marks. It is very important topic as per as your dye industry concern. In this particular topic, we are going to prepare the dyes in the laboratory as well as we are going to write the synthesis of these dyes. In this semester, we are going to deal with the subject Chemistry of Aromatic Compounds and Dyes. And very first topic from this subject is aromatic hydrocarbons. In the last semester, you have learned about aliphatic compounds, that is alkane, alkene, alkyne, aldehydes, ketones and so on. Now, in this semester, we are going to deal with aromatic hydrocarbons. Now, what is the difference between aliphatic hydrocarbons and aromatic hydrocarbons? Aliphatic hydrocarbons are straight chain compound in which carbons are arranged in a straight chain or sometimes in a branch chain. Sometimes there are close rings also present in which carbons are attached to each other by a single covalent bond. They are called as a cyclic compound. In case of aromatic compound, carbon atoms are attached to each other by alternate single bond and double bond, and they are arranged in the form of closed ring. You will find the structure of benzene and cyclohexane. Now in benzene carbon atoms are 6. In cyclohexane also carbon atoms are 6. But in benzene carbons are arranged alternatively by single and double bond, while in cyclohexane carbons are arranged in a cyclic manner, but only single bond is present in between the two carbons. Aromatic hydrocarbons are unsaturated hydrocarbons which are a ring compound in which there is conjugate single and double bond system. And aliphatic hydrocarbons are straight chain compound in which there may be single bond, there may be single bond or double bond, and there will be cycle also, or they may be cyclic also. But this structural difference makes them to change their physical properties like boiling point, melting point. Boiling point means the temperature at which the vapor pressure of the liquid becomes exactly equal to the atmospheric pressure and the liquid converts into the gaseous phase. So this structural difference makes them to differ in their boiling point due to the presence of conjugated system. Now you will find boiling point of benzene is 80 degrees Celsius and boiling point of cyclohexane is 81 degrees Celsius. So this conjugated system is responsible for decreasing the boiling point of the benzene through 1 degree Celsius. Generally, aromatic compounds are volatile and they are having less boiling point and melting points in comparison with the aliphatic compounds. Aliphatic compounds and aromatic compounds also differ from each other in their burning behavior. Aliphatic compounds generally burn with blue color flame. In laboratory or in a domestic gas stove, you have seen blue colored flame. So the fuel which is used there is LPG, that is liquefied petroleum gas. This LPG is composed of aliphatic compounds like ethane, propane and butane. So when these compounds are burned, you will find blue color flame which is sootless, or we call it as a non-sooty flame. But in aromatic compounds, you will find sooty flame. When these compounds are burnt in presence of air or oxygen, they will form a flame which is generally yellow in color, and at the top of flame, if you hold your hand, you will find the tiny carbon particles are accumulated on the surface of your hand. So sooty means carbon containing flame, or the flame which is generating carbon. In this way, aliphatic compounds and aromatic compounds are differing in their burning behavior. Odor or smell is next physical property which we can consider for identifying the aromatic compounds. Generally, all aromatic compounds have specific sweet smell. They are named as aromatic due to this property. Such compounds are present in fruits like apple and all citrus fruits. These compounds also present in spices like black pepper, cinnamon, which we use in our foodstuff. Their smell itself is their identity, which is used in preparing synthetic flavors also. While aliphatic compounds are having smell, but it is not specific. So in this way, we can differ aliphatic and aromatic compound using this property. Aliphatic compounds are generally used as reagents and solvents. These compounds are more reactive in comparison with aromatic compounds, while aromatic compounds are highly specific about their reaction. They require critical condition of temperature, pressure, and catalyst. Based on these properties, aliphatic compounds and aromatic compounds have their application in various fields. Generally, aliphatic compounds are used as a solvent like paint thinner, antifreeze coolant. They are also used as a lubricant. You might have learnt their use as a lubricant, as a grease in first semester. While aromatic compounds are used in various industries like manufacturing of plastic, drug industry, oil paints, manufacture of certain fibers like polyester, then they are used in manufacture of dyes and pigments also. So in this way we have seen the difference between aliphatic compounds and aromatic compounds. In this slide, the difference between aliphatic and aromatic compound is summarized. First thing is the structure. How do they differ from each other with respect to their structure? All aromatic compounds are ring compounds, means you will definitely find a ring of carbon atoms in all aromatic compound. While in case of aliphatic compound, the linking of carbon compound take place in a straight chain like fashion. Second thing is the saturation. In case of aromatic compound, each carbon is attached to each other by alternate single bond and double bond. And for the same number of carbon atom, aromatic compounds have lower boiling point and melting point. Aliphatic compounds are both saturated as well as unsaturated in nature. That is, they contain single bond, they contain single bond and double bond. Sometimes they contain a combination of single bond and triple bond also. And for the same number of carbon atom, aliphatic compounds have higher boiling point and melting point. Example of this we have already seen in previous slide, that is benzene's boiling point is 80 degrees Celsius while the boiling point of cyclohexane is 81 degrees Celsius. So the conjugation has decreased the boiling point through 1 degree Celsius in case of benzene, while in case of cyclohexane the boiling point is 81 degrees Celsius. Now let us turn towards the flame test. Now what is meant by flame test? If you burn any aliphatic or aromatic compound, definitely you will find a flame. But their structure is different, their color is different. In case of aromatic compound, when you burn aromatic compound, you will find a sooty flame. For example, if you burn a camphor, kapur, you will find a sooty flame. When you hold your hand on this flame, your hand get turned black. But in case of aliphatic compound, the sooty flame is not observed. It is generally blue color flame. In case of your LPG, you will find blue color flame. It is a combination of ethane, methane, propane, butane. Such type of aliphatic compounds are present in LPG gas. Now let us turn towards the next property, that is odor. All aromatic compounds are having pleasant odor, while aliphatic compounds are having unpleasant odor. Odor means smell. If you see the compounds which are made up of aromatic compounds such as your fruits, then your food stuff, all these contain some flavors which are added or which are present inbuilt in them. But in case of aliphatic compound, the odor is not particular. Now you can see the example of kerosene. Kerosene is having bad odor. Petrol, it is also aliphatic one. It is also not having so pleasant odor. So that is the main point of difference, that how easily you can differ aliphatic and aromatic compounds from each other. Now the next point is reactivity. Aromatic compounds need special conditions to react because aromatic compounds are having some stability, which is their extraordinary property, in comparison with aliphatic hydrocarbons. Aliphatic hydrocarbons react more freely or easily, but aromatic compounds need some reagent, some special conditions like temperature, pressure, catalyst to carry the reaction and convert the reactants into the products. Now you are knowing the examples of aromatic and aliphatic compounds, benzene and naphthalene. They are having their special aroma, flavor, odor, and hence they are aromatic one. While aliphatic compounds are butane, propane. Already we have discussed it in the second semester. Now, depending on their properties, they are used for different purposes in various industries. Aromatic compounds containing ring of 6 carbon and their combinations are used for creating new and more applicable compounds like pharmaceutical drugs, pesticide, uh, dyes, pigments. Usually, the aliphatic compounds are used as a solvent and they are used to carry some reactions in laboratory. So, this is all about aliphatic compounds and aromatic compounds. In this way, the first point from your syllabus, from the first topic, we have completed. Friends, let us turn towards the next point, that is, how do these aromatic compounds look and how do they form the ring?